Hello students, welcome everyone. So in the last video we have discussed the concept of thunderstorm, right? So in this video we'll discuss about how a thunderstorm becomes a cyclone. So first of all we have to know something about cyclone. So what is cyclone? First of all, it is a huge revolving storm. Cyclone is what? Cyclone is a huge revolving storm. Okay, it is a huge revolving storm and it is caused by very high speed winds. Okay, it is caused by very high speed winds blowing around a central area of low pressure in the atmosphere. That means if there is a region, okay, if there is a region and if it is getting heated, okay, if it is getting heated from the sun rays falls on it, suppose like this. Okay, if this region is getting heated, then the air over this region will rise up. Okay, the warm air rises up. So if the warm air rises up, what will happen? There will be a creation of low air pressure region in this part only. Okay, this region has a very low air pressure now. What will happen? Due to this, the cool air from the surroundings rushes in to take the place of warm rising air. Okay, and this cool air blows with a very high speed. Okay, this air blows, or we can say this wind now. Okay, the cool wind blows with a very high speed, okay, to take the place of hot rising air. Okay, so due to this process only the cyclone is caused. Okay, clear? So let's see this, what is given in your book, how a thunderstorm becomes a cyclone. You know that water requires heat when it changes from liquid to vapor state. That means yes, when you want to, or if you want to convert the liquid form of water to the vapor form of water, what you have to do? You have to heat it, right? Next, does the water give back heat when vapor condenses into liquid? That means if you want to convert the vapor form of water back to the liquid form of water, you have to cool it down, right? You have to cool it, and that process is known as condensation. So during the condensation process, does the heat is given out from the vapor state? Yes, the heat is given out. Okay, does the water give back heat? Yes, the water is the heat is given out by the vapor form. Okay, which will warm the atmosphere. Okay, which will warm the surrounding media. So now let's talk about cyclone more. Structure of a cyclone over here. You see, the center of a cyclone is a very calm area and it is called the eye of the storm. Okay, see, a cyclone is formed over warm sea water. Okay, a cyclone is formed over warm sea water and it is about 10 to 15 kilometers high, and the revolution of cyclone, okay, or say we can say that a cyclone revolves due to the force exerted by the rotation of earth. Okay, why the cyclone revolves? It is because of the rotation of earth. Okay, a cyclone revolves due to the force exerted by the rotation of earth. Clear? Also, as we have mentioned already in the beginning, that the center of a cyclone is a calm area. Calm area means what? Here, calm area means that the area has a very low air pressure. That means the pressure of that area is very low. Okay, it has a low pressure region, low air pressure region. Okay, and the diameter the diameter of the eye of the cyclone. See, first of all, you see what is eye of the cyclone here. This region is to be mentioned here. This region is the eye of the cyclone. Okay, clear? It is the center of the cyclone. This is the structure of cyclone, and this eye is the center of the cyclone. Okay, and this diameter, the diameter of the eye of the cyclone varies from 10 to 30 kilometers. It varies from 10 to 30 kilometers. Okay. So a large cyclone is a violently rotating mass of air in the atmosphere, say 10 to 15 kilometer high. The height of the cyclone can be about 10 to 15 kilometer, and the diameter of the eye varies from 10 to 30 kilometer. Okay. Next, it is a region free of clouds and has light winds. That means in this region, the eye of the cyclone, the center of the cyclone, in the center of the cyclone there is no clouds. It has only light winds. Okay, light winds. It has only light winds. Okay. Around this calm and clear eye, there is a cloud region of about 150 km in size. And in this region, there are high-speed winds, say from about 150 km per hour to 250 km per hour. And from this thick clouds, heavy rain falls. Okay, and thick clouds with heavy rain. Understood? That means around the center of the cyclone, or we can say around the eye of the cyclone, there are thick cloud regions. Okay, there are thick cloud regions, and the size of the cloud can be about 150 kilometer in size. Okay, the size of the cyclone can be size of the thick clouds can be about 150 kilometers. Okay, and in this thick clouds, what is there? There are very high speed winds, and the wind speed can be of about 150 km per hour to 250 km per hour. Okay, and from the thick clouds, this thick clouds produces heavy rain. Okay, and this moves in circle around the eye. This moves in circle around the eye, moves in circles. Okay, this moves in circles like this. Okay, around this eye. Okay, together only this is as a whole forms what? Cyclone. Clear? Are you getting it? Also, one more important thing, that away from this thick clouds, if you go away from this thick clouds, then the wind speed gradually decreases. If you go away from this thick clouds, then the wind speed gradually decreases. Okay, clear? So the formation of a cyclone is a very complex process, and a model is shown in figure 8.11, which I have shown just now. Clear? So now comes how a cyclone is formed actually. See, in the beginning only I have mentioned that a cyclone is formed in the atmosphere over warm sea water. It is formed over warm sea water. Okay. Okay, and it is formed actually during the hottest summer months. And some of the factors which contribute to the development of a cyclone are temperature. Okay, temperature is there, humidity is there. Okay, then comes your wind speed also is there. Okay, these are some of the factors which contribute for the development of cyclone. Okay, for the creation of cyclone. Wind direction is also there. Okay, then comes the rotation of earth. Due to the rotation of earth only, the rotation of earth exerts a force. Okay, the rotation of earth exerts a force, and due to this only the cyclone revolves. Okay, due to this only the cyclone revolves. Okay, due to the force exerted by the rotation of earth. So these are some of the factors which contribute to the development of cyclone. Okay, so now let's see what is given in your book. Before cloud formation, water takes up heat from the atmosphere to change into vapor. Okay, see, suppose there is a sea, like this sea region is there, sea water is there. Okay, see, this is a sea water. Okay, and during summer the sun will heat the sea water, right? The sea water will get heated. Okay, the sea water will get heated during the summer months. Okay, now the warm and moist air from the sea rises up very rapidly. Okay, the warm and moist air from the sea rises very rapidly, and this will create, the warm and moist air from the sea rises rapidly, and this will create a region of very low air pressure, which causes the cool air. If the warm or say moist air rises high, it will create a low air pressure region, and which causes the cool air from the surroundings, okay, which causes the cool air to rush in to fill the vacant space of the warm and moist air. Okay, the cool air will come in towards the place of warm air to take its place. Okay, so this water takes up heat from the atmosphere to change into vapor. Now the water is risen up. Okay, the water took the heat and it rises up at a very high, or at a very high place. Okay, so when water changes back to liquid form as raindrops, this heat is released to the atmosphere. That means, as the warm and moist air, which contains a vapor also, which contains water vapor also, that means the warm air which is risen up from the sea water, right? The warm air which has risen up from the sea water, this water also contains water vapor. Okay, so the warm and moist air which contains water vapor rises high up in the atmosphere, and it will get cooled because it is at a high place, right? It is at a high altitude, so it will get cooled, and the water vapor present in it will condense to form thick clouds. Okay, and also it will release a lot of heat in the atmosphere. Okay, the warm and moist air, if rises up, it rises up, then it will reach a particular altitude, then it will condense, or it will cool down, or it will condense to form thick clouds, and it will also release a lot of heat to the atmosphere. Okay, this is only what it is written. When water vapor changes back to liquid form as raindrops, or it will form as clouds first of all, then it will release heat to the atmosphere. Okay, so the heat released to the atmosphere warms the air around. Okay, the heat released by the condensation of water vapor in the atmosphere warms the air all around it. Okay, so the air tends to rise and causes a drop in pressure. That means the warm air which rises higher into the atmosphere causes a low pressure area. As I already mentioned in the beginning only, the sea water which gets heated, it will rise up and it will create a region of low air pressure. Okay, drop in pressure means what? A drop in pressure is written over here, right? Drop in pressure means it will create a region of low pressure. Okay, drop in pressure means the pressure will be lowered. So more air rushes up to take the place of warm rising air, and this process is repeated again and again. So the warm air which rises up, it will create a drop in pressure, it will create a low air pressure region, and the cool air will rushes in towards it to take the place of warm air. So this process is repeated again and again. Okay, this process is repeated again and again, which makes more and more air to rise up. Which makes more and more air to rise up, because this is a continuous process. This process is repeated again and again. Okay, so more and more air rises up higher and higher in the atmosphere, which forms more and more thick clouds all around. Okay, so the air tends to rise, causes a drop in pressure, so more air rushes to the center of the storm. Okay, more air rushes to the center of the storm. Okay, which and this cycle is repeated. Okay, so the chain of events ends with the formation of a very low pressure system with very high speed winds revolving around it. Okay, so you see also that the constant rotation of earth on its axis also exerts a force on the rising column of winds or rising column of air. That means the force exerted due to the rotation of earth helps to revolve the cyclone, right? Revolve the storm. So the force exerted by the rotation of earth makes the high speed winds revolve in the form of a spiral moving upwards with a great force, and it will create a tunnel of very low pressure inside it. Okay, so this swirling winds move faster and faster, which forms huge circles. So this weather condition, consisting of a system of high speed winds revolving around a central area of low pressure, is the cyclone. Okay, and the area of very low pressure at the center of the cyclone is its eye. We can also say it as eye of the cyclone. Okay, clear? So it is this weather condition only that we call as what? Cyclone. So the factors like wind speed, wind direction, temperature and humidity contribute to the development of cyclones. Okay, so these are some of the pictures which shows the formation of a cyclone, the eye of the cyclone, the image of the eye of the cyclone over here. This one. This is the picture of cyclone over here, and this is the eye of the cyclone. Okay, in the center. And here rising water caused by a cyclone. This, if you see it deeply, you can visualize. Rising water is caused by a cyclone. Okay, so that's all over here. We have discussed how a cyclone is formed. So in the next video we'll discuss about destruction caused by cyclones. So that's all for today. Thank you and have a nice day.